Hello, good afternoon to all of my dear students. This is the first class of the new course, Design Thinking and Innovation. This is a nice course, but this is the first time this course is introduced, uh, and this is the full responsibility with me. But I am, as a computer scientist or a computer science researcher, I can give you only some uh, design thinking of some problems related to algorithm design. I cannot give you mechanical engineering design, electrical design, and that will be possibly introduced later on in the next semester. I don't know whether that facility will be available for you or not. I will try to make you available for those concerned students of mechanical engineering and also electrical engineering or some other students. Okay, so let's start this design thinking and innovation. Now you see, can you see this properly? You see this? I think it is visible now. Okay, now you see this. This is basically design thinking and innovation. So here there are four phases of design thinking and innovation. I'm writing this. Initially, it will look fake, but you see, first phase is uh, empathize, empathize, em, em, empathize, and second phase is analyze, analyze. Third phase is solve, and fourth phase is uh, test. And some other book, their phases will be divided, subdivided into in other ways. But what is empathize? Empathize means actually this design thinking is basically human centric, and that is um, actually empathize means you have to look into others thinking, whether some people's on the other end are in trouble or not, in which trouble they are. Think of their problem as your problem, and then try to solve their problem by taking this your problem, that is empathize case, and try to analyze that problems, how do you solve this, and if possible solve it and test it. These are the four phases. I'm just briefing you this, and now I am giving you one problem regarding this, and all the four phases will be subdivided into that problem. Now the problem is, you see, uh, this problem this problem is related to algorithm. Definitely given given uh, set given a set of natural numbers, natural numbers from 1 to n, and and there is a missing number. uh, you have to find out, you have to find out that missing number. That is a very simple problem. uh, Missing number, find out. So what will be your solution? You see this, given a set of natural numbers from 1 to n, and a missing number is there. I'm giving you one example. Suppose this is the array. This is the array. Possibly you can see this. This is the array, and it is 0, 1, 2. These are the indices. 3, 4, 5, 6, 7, 8, and these are stored in array. All of you are knowing about the array. So that means there are the 9 places are here, and I am here. This suppose there are the 9 numbers are there from 1, 2, 3, 5, 6, 7, 8, 9. Suppose these are the numbers. Suppose these are the numbers stored in this array, and some memory is empty, definitely, because you have to find out the missing number and you have to enter here. You see this, what is the missing number here? The missing number here is 4. So that is output will be is equal to 4. And in which position, right? So how do we find this? The very simple solution is, as all numbers are from 1 to n, then you see this, take the sum of 1 to n, then that is sum is equal to n into n plus 1 by 2, that you know this. And you have to make a for loop of here and subtract all the numbers in that given array uh, from this sum. The sum minus a0, sum minus a1, sum minus a2, and every time it is updated. That means sum is equal to sum minus ai. That is, there is a definitely a for loop uh, from I is equal to 1 to n minus 1, and 0 to n minus 2, and sum is equal to sum minus ai. That will give you, ultimately at last you will find out the value of sum, which will give you the output 4. This is a simple algorithm, because the whole 1, 2, 3, 4, 5, 6 up to 9, if you add this, you will get some number, and subtract all the numbers, definitely you will get the missing number 4, right? So this is the simple algorithm. But what is the complexity of this algorithm? This complexity of this algorithm is, complexity is equal to order of n, because you have to take care of all the elements stored in the array. So now the question is, this is the problem. Now, what is the empathize stage of this problem? Now, this, suppose this has been given by some computer scientists. That means this is, from the algorithm's point of view, this is a product, and its behavior is, complexity is order of n. And now you have to think that if you can think every product as an unfinished product, that means actually you are doing the empathize stage, because whether it can be improved better, so whether the running time can be improved, so that your new design will be efficient. Now, how do you do this? And you see this, the simplest way, you see this, what is the observation here? The stored element are in the sorted array. That means basically there is a notion of binary search. It may be applicable. I don't know whether that, if the binary search can be applicable here, then its running time will be order of log n, that you know already. Whether it will be applicable, then your design will be better than the previous one. Then your product, in terms of algorithm design, it is the good one. It is the now the better one rather than the previous one. So right, this is the analyze phase. First, empathize this. That where is the problem from the user's point of view? Oh, this running time is order of n. It is so it will take more time. But this is the client's point of view. Now you are thinking, analyzing this. What is the second phase? That is analysis phase. That is, as the numbers are in the sorted manner, so possibly binary search can be applicable. But how it can be applied, I don't know. We will have to try for this. Now, so this is the analysis phase. Now solve it, whether it can be solved. Now you see what is the thing when you are doing this binary search. What you will do this everything that you see in 0th place, it is 1. It 1th place it is 2. That means the index, the number stored is 1 more than the index here. But where the missing number is, that is number is 2 more than the index. You see this. That means basically, if you can find out the value where AI is not equal to AI is not equal to I plus 1, that means actually I plus 2 here, then you can find out the missing number. That how it can be found. Now you see, again I will there's a, I will erase this, and I want to solve it. Here you see this example, and just remember the binary search algorithm the same. What is the terminating condition? Why? That means if you see, if AI is not equal to I plus 1, what does it mean? You see, suppose you are doing 0 AI 0 and 7 by 2. L is equal to L is sorry L is equal to 0, and here R is equal to 7 for this example. So I is equal to L plus R by 2, that is here 3, as we are taking the integer value. So 3 means here this is third position. You see this, in third position, what is the value of AI? That is 5. That means AI is not equal to I plus 1. And at the same time, you see, a I minus 1 is equal to I. You see this, equal to I. I minus 1 means that's the previous index. That previous index, that is 2, is equal to I, exactly 1 more than this one. Then what is happening? Then report means printf report I position means this position report I plus 1. That means this I plus 1 is your missing number. Now it is clear. That means this is the terminating condition. Else, if it is not true, that means this is not true, this is not true, or this is not true. That means basically, when it is the case, you can take this in this way. Suppose I'm giving this example. This is 4 and this is 6. That is 5 is the missing number. So what is the value of 3 here? This is mid value is I is equal to 3, equal to 3. But you see this, AI is not equal to I plus 1, so this will not satisfy. What does it mean? That means this is equal to I plus 1. That means if AI is equal to I plus 1, what does it mean? It means actually from the beginning till there is no missing number from that very I position, right? That means definitely that missing number will be on the right sub list of the whole list. That is, this I means mid value. Actually this I is basically stands for the mid value. So I is basically updated to low will be updated to I plus 1. Am I clear? Because in I position you see that this is 3 here, in S position this is I plus 1. That means before that there is no missing number. So you have to take care of the right sub list for the entire next part. That means you have to check for the low value will be I plus 1 and R value will be 7. That means low value is 4 and R value will be 8. Now you have to check similarly in this way for this. Else case will be there. Here no place is there. That else high will be if this is not equal to, actually this is not equal to means there is a gap. That means definitely the missing number will be on the left subnet. Then high will be reassigned to I minus 1. Am I clear? Yes, high I minus 1. So this is the idea. Now you see this and this whole thing will be within while loop, that is while L less than equal to R, then it will be running. Then when L greater than R, then the loop will be terminated. In the meantime, if the missing number is found somewhere, then you will report that element, and you can use here in the middle break statement so that it will not run anymore. That means you see this, this the important thing is binary search now is applicable for this problem. And now the complexity of the new algorithm is order of log n base 2. Every time we are doing the half of the sub, we are searching in the half of the previous list. So that's why it is log n base 2 complexity. This is much better than order of n. That means if there are 1024 elements, then only 10 after 10 or 11 steps we can find out the missing number. And if there is 2048 elements, then only 11 or 12 steps we can find out the missing elements. So this is a much better algorithm than the previous one. That means your new design and innovation with the help of some mathematical properties and the structural properties of the stored element in the array will help you to thinking the more better design for the that given problem and the previously solved problem. So this is new innovation for that for a given problem, and this is basically design thinking innovation. So solve it and you can test it for any set of data, and any set of data you can check it for any set of data. And there are some cases if the element stored here it is the size of the array, that means overflow will occur. You can find out the missing number, but you cannot insert within this number. So these bookkeeping jobs, these degenerate cases will be taken care of at the time of writing program. So you have to write the program for these two cases. But the first case is order of n complexity. How do you solve this? Write a C program for that, and write a write a better algorithm with the help of C program. Do this. So your assignment is you have to do the two programmings with the help of C programming languages, that is, and whose complexity to order of n, that is the previous one, and this the second one whose complexity order of log n. Try to complete this assignment within 2 days. Okay, you can see the in the Google Classroom. You will be notified that these are the assignments. You have to do this. Thank you very much for hearing me. I don't know, this is my first class for design thinking and innovation, how it is. Okay, thank you very much.